Hello, welcome to lesson 1.4. We're going to be talking about factor pairs and prime factorization and factor trees, all kinds of good stuff on lesson 1.4. This is found on page 26 in your textbook. You can also use the digital resource if that's easier for you. Like I said, here's our vocabulary: factor pair, prime factorization, and factor trees. I would suggest that you write those terms down in your math notebook. And I did that. I wrote down all my definitions, and I even went back and I wrote out what factor pairs are, what prime factorization is, and what factor trees are after I finished going through my lesson. You'll also notice that at the top of the notes, I put the lesson name or the lesson number, what I'm working on, the date, and the pages that we're going to be working on. Factors are really super important in just doing math, but especially with the fraction work that we're doing coming up. Oh yeah, fractions. So you're definitely going to want to make sure that you understand this part. There are parts that you may want to use a calculator on if you're a little sketchy on your math facts. Hopefully you've been practicing them. If you need resources, let me know, and I'm happy to help you find some resources. This first part where you're finding factor pairs, there are places where you're going to need to know places in life where you're going to need to know factors. Not many of you will end up being band directors. I don't think so, but you still need to know how to arrange things in rows and columns. Here you go. So the brass section of a marching band has 30 members. The band director arranges the brass section in rows. Each row has to have the same number of members. How many possible arrangements are there? So what you do is you look for your factor pairs there. So factor pairs are numbers that are multiplied together to get a product. So up here, it kind of goes over that part. 2 is a factor of 10 because 2 times 5 is 10. And so the 2 and the 5 go together. They're the factor pairs. I know that 1 times 10 are 1 and 10 are also factors, but that's not a factor pair. The pair of the two numbers that go together to make that product. So 2 and 5 is your factor pair. And then here is your list of factor pairs for that number 30. I also did some extra factor pair work. Let me show you what I did with extra so you can see other examples of how to do factor pair. I'm going to scooch my book out of the way and show you my notes. Okay, so here are extra examples. I wrote out my paper extra examples because that's what they are. So I was looking for factor pairs of the number 7. 7 is a prime number. It does not have any other factors, any other whole number factors, except 1 and itself. So here's 1. 1 times 7 is 7. There's nothing, no whole number that I can multiply by 2 or 3 or 4 or 5 or 6 to get 7. So my factor pairs are only 1 and 7. That's it. I have one pair. 10 is a little bit different story. I have more than one factor pair because 1 times 10 is 10 and 2 times 5 is 10. So my factor pairs are 1 and 10 and 2 and 5. We'll keep going here. I need a different setup. Man, it's rough, isn't it? Okay, here we go. For 35, I kind of make this little rainbow here. On the bottom, it's like a bottom bow. I don't know. What do I call it? Maybe a bowl. Because it shows my pairs. And once I stop being able to connect things, then I stop having factor pairs. So 1 times 35 is 35. I can't do 2 times a whole number to get 35, or 3 times a whole number to get 35, or 4 times a whole number to get 35. 5 times 7 is 35, so that's another factor pair. So there isn't a 6 that I can use, and then I start repeating 7. So I know that my only factor pairs of 35 are 1 and 35 and 5 and 7. The little bow helps. The other thing that might help you with prime factorization are the divisibility rules. So the divisibility rules are a PDF that's attached to this lesson, so you can look back at it and you can see what the rules are. 1 is a factor of every number, every number it is. 2 is a factor of any even number. Anything that ends in 0, 2, 4, 6, or 8, 2 will be a factor of that. 3 and 6 are kind of cool because if you add up all of the digits that are in the number that you're trying to find as a factor, so like if you're trying to find factors of 27, you add the 2 plus the 7 together, you get 9. 9 is divisible by 3, so 3 is a factor of that. That's the same rule for 6 as long as the number that you add together. So if you take 27, for example, and you add 2 plus 7, it equals 9. 9 is not divisible by 6, but it's the same rule that goes into effect there. That's for 3. 5, anything that ends in a 5 or a 0 has a factor of 5. We just talked about 6. 4, off the top of my head, I don't remember what 4 is, but I know that there's one out there. Hold on, I got to answer that phone call. You can hear it. So use that resource of the divisibility rules to figure out where your factors are, where you're going to find your factors, okay? Next, I want you to try the on your owns 1, 2, and 3, just 1, 2, and 3 on page 26. Go ahead and nope, actually 1, 2, 3, 4. You're going to do 1 through 4. 1 through 4. Go ahead and pause the video right now. Get your on your owns done and unpause and then come listen to me again. Oh, it's so nice to have you back. I hope you had success writing down some factor pairs. Let's go ahead and look at what your factor pairs are. So for 18, I know that 1 times 18 is 18, 2 times 9, and 3 times 6. So I knew that I could stop after 3 because 4 and 5 are not factors of 18. That's how I know that I'm done. Because when I start repeating myself and saying 6 and 3 are factors and 9 and 2 are factors, that's when I know that I've found all my sets. So there's my factor pairs, 1 and 18, 2 and 9, and 3 and 6. Number 2, 24. Wow, 24 has a lot of factor pairs. Did you get them all? 1 and 24, 2 and 12, 3 and 8, and 4 and 6. 5 is not a factor of 24, so then we'd start 6 and 4, 8 and 3. And once we start repeating, we know that we are done. Number 3 changes things up a little bit because there are only 2 factor pairs. Did you find them both? Remember that trick I said about 3? So if I add 5 and a 1 together and I get 6, I know that 6 is divisible by 3, so 3 is a factor of 51. 3 times 17 equals 50. Or 3 times 17, I wrote that wrong. Oh, darn it, I'm glad that I caught it though. Hold on, let me fix this so that when I make copies, you're going to be able to see it. 3 and 17. Okay. Number 4, and to start a new page. I had a lot of notes on this one, guys. I think I had 3 pages of notes on this. All right, the brass section has 8 possibilities. We saw that in our book on page 26. And the woodwind section, the number of woodwind players I have is 38. So my factors of 38, I had to find those first, were 1 and 38 and 2 and 19. Oops, you can't see anything, sorry. 1 and 38 and 2 and 19. So that means my possibilities for my woodwinds would be 1 row of 38 or 38 rows of 1, 2 rows of 19 or 19 rows of 2. So there's 4 possibilities for my woodwinds. And as we noticed in the example number 1, the brass section had 8 possibilities. All right, I want you to pay attention to this key idea right here for prime factorization. This is important and it's good stuff down here. So prime factorization, you use this factor tree and along with factor pairs to help come up with your prime factorization of a number. So here's my example for 60, and it shows it all broken down. When you break down your numbers, so you have the number 60 and you're trying to break it down into prime factors. So prime factor, your prime factorization is going to be a list of all the prime factors of a number in the simplest forms. You cannot have any composite numbers in there. If you're not sure what the difference is between a prime and composite number, you can read it over here, or you can go back to the Edpuzzles that were due on Friday, or I think they were due on Thursday the 15th. Okay? So go back to that if you need some refreshers on prime and composite numbers. But then right here, you'll notice that 60 has factors of 2 and 30. 30 can be broken down into 2 times 15. 15 can be broken down into 3 times 5. So the numbers that are in the little red circles are all the prime factors of 60. So the prime factors are 2 times 2 times 3 times 5. See how they wrote it down? 2 times 2 times 3 times 5. And then this is where our understanding of exponents is going to help us out, because it should be written as 2 to the second power times 3 times 5, because 2 times 2 is still 2 to the second power. I did that work, I redid it, and I have some extra examples. So there's lots of ways that you can make your factor trees, lots of different ways that you can break a number down into factor pairs to start off. So just like I said here, there are many ways to make a factor tree, but you're always going to end up with the same prime factorization. So the book has one example of how to break 60 down into factor pairs, but then I had 5 times 12 to equal 60 and 6 times 10 equals 60. All of those are going to lead to the same prime factorization, 2 squared times 3 times 5. You only have to show one way of a factor tree. I will give you lots of examples because they're important. We are not doing example number 3. It's not something that you guys need to worry about. So skip example number 3, and I want you to go ahead and focus on the on your owns on page 27. Only do numbers 5 through 8. You only have to make your factor tree one way. Definitely use the prime. Let me say that again. Use the factor tree. Use the factor tree. Okay. Do I have to use the factor tree? Yes. I want you to use the factor tree to get your prime factorization of 20, 88, 90, and 462. Pause the video. Find the prime factorization of those 4 numbers for 5, 6, 7, and 8. And then unpause the video and you can check to see if you got them right. All right, let's see how you did. So, like I told you before, I'm going to do 2 different factor trees for each number. You only had to do one. I'm showing you that there are many ways that you can get your prime factorizations, but you only need to do one of them. All right. So 20 has a factor pair of 2 and 10. 2 is the prime factor, and then 10 is still a composite. It can be broken down to 2 times 5. 2 and 5 are both prime numbers. So then if I wrote it as a product of its factors, it's 2 times 2 times 5, or 2 squared equals 5, or 2 squared times 5, sorry. And then for 20, another way that I can make factor pairs, my 5 looks funny over here. Okay, is 4 times 5. 5 is a prime number, that's why I circled it. I knew I could stop there. 4 is a composite. Its prime factors are 2 times 2. So again, I have 2 times 2 times 5, which is equal to 2 squared times 5. I came up with the same prime factorization no matter the factor tree I used. Miss Smith, I can do this in my head. Show your work. It doesn't matter. I need you to show your work, okay? Let's flip over to number 6. I told you guys I took a lot of notes on this one. This one was note heavy. It's important that you show your work though. All right, 88. Again, I have dueling factor trees over here. So I know that some factors of 88 are 2 and 44 and 8 and 11. So over here, I've got 2 times 44. 2 is a prime factor. 44 is a composite number. 44 has factors of 4 and 11. Again, 11 is a prime number, so I circled it. 4 is a composite. It can be, its prime factors are 2 times 2. So then it's 2 times 2 times 2 times 11, or 2 to the third times 11, 2 cubed times 11. Same answers over here. Check that out. 88 has prime factors of 8 times 11. 11 is, again, is my prime number, so it's circled. Then I have 2 times 4, circled my prime. 4 gets broken down into 2 times 2, 2 times 2 times 2 times 11, and that equals 2 cubed times 11. Here we go for number 7. Again, I started off with 2 times 45 as a factor pair, or 9 times 10. They both get broken down and they equal the same prime factorization. There is only one, there are lots of factor pairs, but only one prime factorization. Number 8 was tricky because it was a really big number. Maybe you use some of those divisibility rules that it's an even number, so you knew that 2 was one of the factors. Maybe you added things up and you knew that 4 plus 6 plus 2 equals 12, so 12 is divisible by 3, so you use 3 as a factor. There's lots of possibilities here, but your prime factorization is still 2 times 3 times 7 times 11. All right? If you have questions on this, let me know. Rewatch the video. Look at my notes. I'm going to make copies of these notes and post them in this assignment as well. And then here is your assignment for prime factorization. You're doing your homework on page 28. It'll start on page 28. We're kind of dotting around doing work, so pay attention to whether or not you need to do the numbers. Notice that 9, 13, 17, 21, those are all odd numbers. The answers for those odd numbers are in the back of the book, so you can go back and check. It's not going to tell you how to do the problem. It's not going to show you the work, but it's going to tell you right away whether or not you have the right answer. Use that as a resource if you need it. If you have any questions, let me know, please. Thanks. See you guys. I guess I saw you in class, but I'll see you guys again tomorrow. Bye. Oh, wait, no, I'm posting this on Tuesday. I'll see you guys on Thursday unless you need help. Come to my office hours, 10:30 to 11:30. Also use the academic support Zooms if you need it.